Welcome everyone. So in this video, I'm going to do a walkthrough of the solution to the first exam, which went really well as a class. I was really excited to see how high the average was. I mean, I write the exam with the goal of having it be an 84 average. If, there's 4 points per question, if I guess wrong, and students on average get one question more wrong than I was expecting, that's an 80. One question more right than I was expecting, it's an 88 on average. If on average people get 2 questions more than I was expecting, then we're like in 92 territory, which is pretty close to what we're at here. And so I was really excited that the class did as well as you have. I mean, it's tremendous. I actually haven't had an exam average this high since 2013 when I was teaching intermediate micro at Pitt. And so that's really, it was really great to see. I'm really pleased to see the high exam score. I'm a little bit anxious. Like, I don't want you to let your guard down for exam 2. So I've got exam 2. I don't do anything special. Like, I don't change the exam. I don't make it more difficult. Exam 2 tends to be more difficult on average. And that's important to know. And I'm a little bit anxious about it because after exam 1 went so well, I worry sometimes people would sort of downplay going into exam 2. So don't make that mistake. Historically, the second exam, historically exam 1 average tends to be, like, I tend to do pretty good job. Usually it goes between about 84, 86. And historically the exam 2 average ends up being somewhere in about like the 80, 88 range. I've had recent exam 2s fall down in like 76, 78 range. And so, then the final exam tends to be somewhere between exam 1 and exam 2, just like looking at my past exams over since 2017 when I started teaching 101. And so I think that's important kind of context to know and kind of think about being strategic heading into exam 2 with your studying and then the final exam. Like, definitely don't let your guard down. Still, keep up the good work. I'm proud of how everyone's doing. I think, working really hard. It's actually, so I'd way rather guess wrong and have students do better than I was expecting than worse. And so that's good. On the other hand, it sort of invites this sort of moral hazard problem. So moral hazard is like if you don't take precautions to kind of take care. So we'll talk about that at the end of the course, actually. Be something we'll cover when we think about asymmetric information, but it invites a little bit of a moral hazard problem, like failing to take adequate precautions and basically failing to like study hard for exam 2. So like, definitely don't fall into that trap. Okay. So the other thing that I'll say is, the exam average, and therefore at this point, like the course average is really high. And I think that's awesome. Like I mentioned on the syllabus, if it turns out that grades are like lower than I had expected, then there'd be some type of curve or whatever to create a situation where like at least 40% of the class had an A and at least 80% had some type of B. So the cutoffs for like A- and B- would go down if necessary to invite those proportions of A's and B's and then C's and so on. But I would never curve the other direction, right? And so if it turned out that for whatever reason, like everyone in the class was over 90%, like that's not going to happen. But suppose it did, that's awesome. That's just like, that's what would happen. And so I wouldn't ever have a situation. So in other words, like you can guarantee yourself of getting at least an A- by earning a 90% in the class, right? So like if you have a 90, that's at least an A-. Probably, like, it'd be weird. I don't think this semester could, after exam 1, I don't think there'll be a curve because people have done so well in exam 1. Like exam 2 would have to go really poorly for there to end up having to be a curve in the class and the final, actually. Probably I don't see that happening. I think probably what's going to happen is we'll have pretty high grading distribution just by virtue of how the exam scores go. And I think that's awesome. That's actually kind of the preferred outcome, is where your grade is just what it is, again, calculated against the breakdown 90, 80, 70, 60. And so anyway, I think that's kind of what we'll kind of plan on and kind of expect. I'd be surprised if, given how well exam 1 has gone, I'd be really surprised if exam 2 went absolutely terribly, right? I don't think exam 2 is going to go as well as exam 1 just based on history, but I don't think I'd get as an extreme surprise in the other direction as this was in the positive direction, right? So I don't know. Maybe that only hopefully that makes sense to more people than just me. But anyway, all right. So I'll go over the solutions now. So there's 5 questions per chapter, and then they're picked, kind of randomly from within these groups. And so there's no numbers here. And if you're looking at your own exam, I don't know, probably what I would do is I'd use like the find on the page thing for like the phrase to be able to keep track. Or maybe you've looked over them enough, or you just really want to pay attention to the ones that you got wrong. And so that might be the most efficient way. But anyway, so the odds of this exact ordering matching your exam is low. So anyway, all right. So following the rational rule, the economic surplus is maximized. Yeah, rational rule is basically saying, we are going to keep doing the activity as long as the benefit is at least as big as the cost. And so the point at which economic surplus is maximized is going to be where marginal benefits equal marginal cost. Now, for the buyer, then you'd have the rational rule for buyers would maximize buyer surplus. For the seller, rational rule for sellers will maximize seller surplus. And then we'll have all these other different rational rules that'll sprinkle in for exam 2 and then for the final. And they're all going to have the same basic idea, which is you want to keep going until the point where marginal benefit equals marginal cost, because that's going to be the maximization point. And there's actually, so marginal benefits equals marginal cost. There's actually kind of a calculus reason for why that's the optimum, but that is the principle. All right. So when using the marginal principle, the seller has to decide whether to supply one more unit of the item. Right? The marginal principle, you're breaking down the decision into, should I supply one more? Because we're talking about from the perspective of the seller. When using a cost-benefit principle, a seller has to, compare the marginal cost of producing the item to the price it gets for the item in the market, right? The one that's designated as the correct answer here is like the cost-benefit principle portion of the rational rule for sellers, right? So the price that it gets for the item, that's the marginal benefit. It's actually in a competitive market, that's the marginal revenue, because each additional unit gets exactly that price. And then there's the marginal cost. When you're literally comparing the marginal cost to the marginal benefit, marginal cost to the price in this case, that comparison is the cost-benefit principle. Yes, when you incrementalize, you get a marginal cost and you get a marginal benefit, but that's the application of the marginal principle. But literally comparing marginal benefit to marginal cost is cost-benefit principle. And that's reinforced in the slides and lecture as well. All right, so the opportunity cost principle says the true cost of something is the next best alternative you have to give up to get it. When I think of opportunity cost as sacrifices, it's what you give up when you do one thing instead of another. The interdependence principle says your best choice today depends on all the following except the past decisions you've made. This is like sunk costs, right? So the past is irrelevant for future decisions. Expectations about the future. Yep. And then, matter of fact, that's like a demand shifter, right? Other decisions you're currently making, sure. Like your decisions affect other things because this will involve trade-offs. If you make one decision, maybe that now constrains your choice set for the other decisions that you're making and decisions others are making. Yeah, this is like if you decide to take a class that there's one less seat in that class for somebody else, and vice versa. So this is sort of reinforcing the examples from lecture. All right, so chapter 2, these are the demand questions. Jane goes to an all-you-can-eat restaurant, makes 3 trips to the buffet. After finishing food from their 3rd trip, they fall sick and throw up. Which of the following best matches Jane's description? Well, so we have a situation where the marginal benefit from the 3rd plate was negative, as evidenced by the fact that they got sick, right? So, I don't know. So we don't know anything about how much they were charged. Marginal benefit from the 3rd trip is benefit than marginal benefit from the 2nd. No, absolutely, absolutely not. So you could cook up something weird where this is perfectly consistent with also it being negative, but that's not the best answer. Jane's marginal benefit from eating the plate. Third plate was positive, but less than that of the second. No, it's not. It's not merely a diminishing marginal benefit question. It's also like this actually made them like way sick, like way worse off. Actually deducted from the utility level. So diminishing marginal benefit, but still positive, would mean like, so for it to be this one, for it to be like A, this would be a situation where Jane would eat the last plate and, still feel largely okay. But the fact that they now feel worse indicates that the marginal benefit was negative. All right, so you go to Starbucks, see the price of your favorite tall vanilla latte has gone up by 25 cents. That's a price change. So as a result of this price increase, you expect to see a fall in the quantity demanded, right? If price changes, only quantity can change, right? And so the other thing is like, even without reading the question, just say as a result of a price increase. Yeah, as a result of a price increase, it's got to be following law of demand. It's got to be a fall in the quantity demanded of whatever is that thing. All right, which of the following scenarios illustrates the law of demand? So Francis doesn't care about the price of coffee at the coffee shop. They must buy 2 cappuccinos every day, regardless of the price. Nope, this would be like really inelastic demand, so kind of ignoring the price, but that's not the law of demand. A research company finds the more expensive brand of a designer handbag, the more consumers are willing to purchase the brand. So this would be like a snob effect or something. And so you get this like an upward sloping demand curve. That's not the law of demand. John likes to drink spring water at $2. They buy 4 bottles, and at $1.50 they buy 4 bottles of water. Okay, so this is again what? Unresponsive to changes in price, and so that also violates the law of demand. Nope, it's got to be the last one. And indeed, Kathleen eats more steak when the price is low, and less when the price is high. Yeah, that's the law of demand. Fast food is a good example of an inferior good. So it's not a normal good. We'd expect as your income rises, you eat less fast food. I mean, you could think of just even in the extreme. So if your income really, really rises and you get, so think of like, Tom Brady now has a personal chef or whatever, so probably doesn't eat a whole lot of fast food. And that's, probably different than what Tom Brady was doing, while here in college, right? So anyway, so as your income rises, you consume less of it. So then we know that good is an inferior good. Now, it's not a luxury good, not a good of the congestion effect. A good of the congestion effect would be something with, as more people consume it, your value for that thing falls. It's like the opposite of a network effect. No, that's not fast food. All right, so shifts in market demand can result from a change in, here we're just looking for our demand shifters. So the only one that fits is the number and type of buyers. The number of buyers, this is relevant for, and type of buyers. So a change in the number of buyers expands the market. Change in the type of buyers is relevant for like network effect and stuff like that. Let's see. So the price of a product, cost of production for an item, that's a supply thing. Number of producers of an item in a market. Type and number of buyers is the only demand shifter. All right. So let's see. Paper producers can manufacture both printing and drawing paper. Oh, they're substitutes in production. So I have to show you my picture. So here we have printing paper, here we have drawing paper. If we have an increase in the price of printing paper, we get an increase in quantity supplied. If we get an increase in price, right, increase in quantity supplied. For drawing paper, we'll get a decrease in supply. What's happening? Well, we're recruiting resources that would have gone from drawing paper to put into making printing paper, which is now relatively more lucrative. So the supply of drawing paper will decrease. Okay, so, and the other thing here is you have to pay attention to which of the markets. So so the raising price in the market for printing paper, and then we're studying the market for drawing paper, right? So the change in the price, and then it was in printing paper, and then the good under consideration, the one that we care about, is drawing paper. All right. Price of jet fuel rises. Oh, that's an input, right? So a change in the price of an important input means a decrease in supply, right? All right. If a firm expects lower prices in the future, oh, they'll spend now, or they'll sell now, and then not in the future, right? So The firm expects lower prices in the future. Think of like something that's storable that they could have potentially sold in the future, and like, no, we want to unload whatever this is now, before, while consumers are still willing to pay for it. So it'll increase supply today, which also, relative to demand, drives actually gives this sort of self-fulfilling prophecy. But anyway, so rising marginal costs rising marginal costs give us an upward sloping supply curve, right? The theory of supply is the theory of marginal cost. And so the vertical height of the supply curve gives us the firm's marginal costs. A supply curve, let's see, plots the quantities of sellers willing to sell at different prices, shows the total cost of sellers, shows rising marginal costs, shows rising fixed costs. What do you think? So it should be 1 and 3, right? Plots the quantities of sellers willing to sell at different prices. Yeah, that's exactly the supply relationship. Remember, supply is just like demand, it's a set of plans. Shows the total cost of the seller. No. Shows rising fixed cost. No. Fixed costs don't typically, yes, we wouldn't typically think of changes in our fixed cost, right? And then shows rising marginal costs. Yeah, right. That's kind of what we said for this one, actually. Okay, so Chapter 4 is now our equilibrium chapter. So what happens to the price and quantity when demand decreases and at the same time supply increases, but the relative size of the shifts is unknown, right? What happens now? Well, I mean, I'll show you the picture in a second. You actually don't even need to draw the graph, but I'll draw it anyway because this is a good one for relative size of the shifts not known. It's a good one for like big small method. But let's see. So if we have demand decreasing, I think of this as consumers losing interest in that thing. As consumers lose interest, less is sold, smaller quantity, in equilibrium, and at a lower price. People have lost interest in it. So price has fallen, quantity has fallen. At the same time, supply increases. I think of a supply increase as flooding the market. There's just like a large amount available to purchase. It's no longer scarce. We expect there's a larger quantity, but a lower price. Oh, wait a second. I said lower price twice. One time I had quantity falling, the other time I had quantity rising. So it must be the case. Equilibrium price falls, change in the quantity in equilibrium is ambiguous. And that's this middle collection of pictures here. So we have demand decreasing, supply increasing. In my left panel, I have a larger shift for demand than for supply. And in my right panel, I have a larger shift for supply than for demand. Now, I like drawing, here I've labeled like D1 and D2 and S1 and S2. I also like drawing my initial with a bolded line and my subsequent with a dashed line, because sometimes you don't have colors, like and you're not able to indicate, like if you have different like colored pens or something, then it works really nicely. But if you don't, I just like using these dashed lines, and then I use like an open and closed circle. I know those mean different things in math, but for interpreting this here, this is how I like doing it. So I like doing bold, and the solid dot for my initial, and then dash, and open circle for my subsequent. So here's my initial equilibrium, here's my subsequent equilibrium. Price fell, quantity fell when demand shifts further, and then price falls, quantity rises when supply shifts further. So I say price definitely falls, and quantity effect is ambiguous. All right. As a result of technological innovation, automated water pumps being installed on the farms of Kenyan tomato farm, as a result, increased water pumps, equilibrium price of tomatoes will fall due to a rise in supply, right? This is an increase in technology. So we're getting a rightward shift to the supply curve. And as supply shifts to the right, that's actually this picture, right? Supply shifts to the right, we get a lower price and we get a larger quantity. An equilibrium price is determined by the intersection of demand and supply. Just kind of true by definition. Graphically, shortages always occur at prices below the equilibrium price. I want to show a graph for a second. So like if we, I don't have a really good one to look at, but so here's our equilibrium. At lower prices, the quantity demanded would be out here, and the quantity supplied would be right here. Like take this one, here's our equilibrium. Okay, let's look at this price right here. I always run over, take my price, bump into the supply curve, go down. Here's quantity supplied. Bump into the demand curve, go down. There's my quantity demanded. Oh, quantity demanded is bigger than quantity supplied. As a matter of fact, that happens at all places below the equilibrium, so we always get shortages at prices below equilibrium. At prices above the equilibrium, we'd always get a surplus. All right. When the quantity supplied exceeds quantity demanded, no, that's a definition of a surplus. At the equilibrium price, nope, that's That's not possible. All right. So let's see. What happens to the equilibrium price and quantity when demand decreases and at the same time supply increases, but the demand shift is relatively larger than the supply shift? What happens to the equilibrium price and quantity when demand decreases at the same time supply increases, but demand shift is bigger? Oh, wait a second, that was this picture. I mean, it's the left panel here, but it's this one right here. So we have demand decreasing, we have supply increasing, but the demand effect is larger, right? Okay, so we have a decrease in price, we have a decrease in quantity, right? So the other way you can read this is you can say, okay, we want to know what's going to happen to the equilibrium price and quantity when we get a decrease in demand. At the same time, supply increases, but the demand shift is relatively larger. You can read that as the supply effect is infinitesimally small, right? And then have only demand changing. And so you just kind of ignore what's happening to supply and say, okay, well, nothing's happening to supply. It's just like an infinitesimally small. Infinitesimal means like arbitrarily close to zero. All right, so if we have demand decreasing, supply is not doing anything, what's going to happen? Well, this is consumers losing interest. And if consumers are losing interest, then price falls and quantity falls. All right. Price of the product is cut by 50%. As a result, the quantity rises by 50%. Oh, cross-price elasticity. Well, this is 50% divided by 50%. It's going to be 1. So actually, once you notice that 50 divided by 50 has to be 1, then you've got this answer here, right? So that was this. So we have 50%, 50% minus 1. The signs matters a lot because that's going to tell us if it's complements or substitutes. If it was positive for cross-price elasticity, then it would be substitutes, because then the price decrease and quantity, price decrease and quantity increase, those are going in different directions. That's where the negative sign comes from. So if we had a price increase and a quantity increase, those are going in the same direction, and that would happen with substitutes. All right, so the price elasticity of demand for a good with vertical demand. You could draw the picture, right? So you just think of like a vertical line. It's got the same quantity, it's got different prices. So you can have this like arbitrarily large change in price with no change in quantity. That's perfectly inelastic. All right, the price of milk at the grocery store is cut by 15%. In response to the price cut, quantity demanded falls by 5%. Absolute value for the price elasticity of demand for milk is, and price elasticity of price elasticity of demand is. All right, so this question, I have a regrettable typo, right? So here we have price falling, and then we have quantity demanded falling, and so this is actually giving rise to this kind of like kind of weird demand curve. So it violates the law of demand. So the typo is regrettable. That said, the correct answer still computes, right? If we have a decrease in price and we have a decrease in quantity, those signs are going to cancel. Well, 5% divided by 15%. So we have like an elasticity of 1/3, and then in terms of interpreting that, right? So it's a 0.33, right? So interpreting this, well, here we had a larger percentage change in price than percentage change in quantity. So yeah, it does violate the law of demand, and it's a regrettable typo, but it's still answerable. The correct answer is still there. If you calculate the elasticity, it's 1/3, and 1/3 we still interpret as being inelastic. That's how we interpret this, and you could actually get something. Early on this exam, right? Earlier on this very same exam, we had an example of what was the handbag question, right? The handbag question where we had here I've made myself dizzy, like kind of skimming. Yeah, a research company finds the more expensive is a particular designer handbag, the more customers are willing to purchase the brand, right? So at higher prices, quantity demanded rises. At lower prices, quantity demanded falls, right? So you could tell a story where that might actually fit. And you know what? In the context of this example, I don't know. Think about milk. If the price of milk is cut by 15%, I'm like, that's kind of weird. They're trying to get rid of this milk, so probably I'm not going to be as interested in buying it. So anyway, I don't like that there's a typo for the question. On the other hand, not only is it still answerable, but it's not. It's also not. It could have, it's still, the question still works, I guess. All right, so price elasticity of demand measures how responsive buyers are to price changes, right? We're thinking about the demand side, and we're thinking about how we're thinking about the response of quantity demanded to changes in price specifically. And then lastly, the price of a dozen eggs rises from $3 to $4.70 in response. Quantity supplied increases from 100,000 to 127,000. What's the closest approximate price elasticity of supply for eggs? Oh, a couple things. So some exams had a different version of this question, but I'm just going to solve this one because that's the one that I've got here. And the other one actually works just like this one. So the first thing that I want you to look at is, so to actually solve this, there's a couple things. Firstly, if you use the midpoint formula, you'll get something that is closest to 0.48. If you use the point elasticity formula, you'll literally get exactly 0.48. However, I didn't want you actually to use the formula at all. And so if you follow this logic, and if this is the logic you use, then in my opinion, you are ready for Econ 401. So look what's happened. We have the price of a dozen eggs rising from $3 to $4.70. Now think about that, right? This is an increase of $1.70. An increase of $1.70 is more than half of 3, right? Half of 3 is $1.50. We've increased by $1.70 to get to 4. That's actually a huge percentage change in price. What about the percentage change in quantity? 100,000 to 127,000, right? Well, 100. Let's just say this is up to like 130. That'd be what, like a 30% increase. So we have a more than 50% increase in price, right? And we got a like just less than 30% increase in quantity, which means we had a way bigger percentage change in price than quantity, which means this is pretty unresponsive supply, right? So we're just going to look for one that's inelastic. Oh, and I only gave you one that was inelastic. So there you go, right? So you've got it. Okay, but suppose you did the calculation. I just want to show this to you, how this would work. So the reason why I said like approximately price elasticity of supply is because I wanted you to be able to get it from using the midpoint formula. And so you get, I mean, I wanted you to be able to get the right answer if you count by like approximately. So if you do the midpoint formula, it'd be 127,000 minus 100,000 divided by their average for, quantities. And then for price, it's 470 minus 3 divided by the average price, 385. So we get 27,000 over 113,500 divided by 1.7 divided by 3.85. And you'll get, this ratio right here, which comes out to like 0.54. If you do the point elasticity, that is if you take the change and you just divide it by the first quantity, and then you have the change in price divided by the first price, right? So whatever, so one of the points was the point 100,003 was the quantity, and then was the price, right? So P1 and then Q1, and then P2, the other point was 4.7, and then 1.27 thousand. Anyway, so if you calculate actually using the point elasticity, then it comes out exactly and as 0.48. But I really didn't want you to calculate it in the first place. I wanted you to look at it and say, oh, wait a second. Here we have this like relatively large percentage change in price, and we have this relatively small percentage change in quantity. That's got to be inelastic. And so, wait a second. There's only one inelastic price, one elasticity of supply that we judge as being inelastic. And so it's that one there. Anyway, I hope you enjoyed the exam. I think probably people on average did, because it went pretty well. And I was pleased to see that. But anyhow, so I'm going to go ahead and conclude the video here. And then I'm going to hope to see, this is finishing this up on Sunday night. I'm hoping my internet will be able to get this up and post, but it might kind of take a while overnight. So hopefully before too long, which means I better stop talking. So, anyway, I'll see you later.